afternoon, everyone. My name is Duane Friend, and want to welcome you. This is the last of our weekly Everyday Environment webinar series. We started this back in early April. I've really appreciated all the interest that we've had from folks, had really good numbers for all of these. We are going to continue these series. We're going to take a little bit of a hiatus during July, and then we are going to come back and have this on a monthly series starting in August. And we should have information on that coming out in the very near future. So if you've liked these, if you've listened to these and other ones, please keep an eye out for future ones that will be starting in August. So today we're going to talk a little bit about clouds, and I'll tell you right up front, the majority of the slides you're going to see are going to be cloud pictures, which is probably what everybody wants to see. We're going to talk a little bit about things before we get into that, so you'll have to sit through about 4 or 5 slides that just have words on them, but then after that we'll get into the cloud pictures. Some of the things I do want to talk about ahead of time is I want to mention the 3 cloud forms that you can find, and probably a lot of folks are familiar with those, but we're going to go ahead and go through them again. I'm going to talk about a couple of other words that are used sometimes to help describe different types of clouds. And then again, we're going to spend most of our time looking at pictures of clouds, describing in some cases how they form, but then also talk a little bit about some of the weather that you might expect or might be associated with these clouds, and a little bit in terms of weather forecasting when you do see certain types of clouds. The other thing I want to do is I do want to show some clouds that you're definitely not going to see here in the Midwest. And you may have seen them in other areas. A few of the clouds you may never see in your lifetime because unless you get to some places like the poles, some of these clouds you will have never seen before and may never see. But do want to, again, try to show you some unique things with that. So moving ahead, just talking about the cloud types, there are 3 main cloud forms that we can talk about, and those are cumulus, stratus, and cirrus. Cirrus clouds are those thin, feathery type clouds. They're really high up. Typically, they're more than 3.5 miles up above ground. And that sounds like it's really high, but if you think about that, 3.5 miles, and we look at the sky and we think of it going on forever. And really, by the time you're about 4 miles up, you got about half of the atmosphere below you at that point. So in reality, our atmosphere is pretty thin. And that's not to say that if you went up to 8 miles, you would be out of the atmosphere. You could go up 1,000 miles above the Earth and still have some air molecules out there. But what we think of the atmosphere as being is very close to the Earth's surface. So the majority of our clouds are actually pretty close to the Earth's surface. Stratus clouds are actually fairly low clouds, maybe only a few thousand feet off the ground, maybe only a few hundred feet off of the ground. And some others may be a little bit higher than that, but those are sheet or blanket-like clouds where they may cover the majority of the sky. You really don't see a lot of form to them other than them just being these dark gray clouds. And then cumulus clouds. Cumulus clouds can take off several different types of forms. These are these puffy, rounded top clouds, typically have a flat base, and that base is usually fairly close to the ground, maybe only a few thousand feet high. Now, a couple of other additional words that we use with clouds to describe them. For clouds that are in middle levels of the atmosphere, and we can talk about different layers of the atmosphere. We're mainly talking about a layer of the atmosphere we call the troposphere. That's where the clouds that we see are typically going to be at in the troposphere. But in the middle level of that layer is clouds that are between 1 to about 3.5 miles up. And with those middle level clouds, and for any of you folks that are musically inclined, you know that mid-range, for a singer in that mid-range is given the name of alto, and we use that with clouds as well. So if we have a cumulus type cloud that is in that level of the troposphere, we add the word alto and we call it an altocumulus cloud. If it's a stratus type cloud, we give it the name Altostratus. So that's where that alto comes from. One other descriptor that we can talk about is when you have clouds that have some type of precipitation coming out of them. And those two words, and you don't have to remember how they would be used, but just know that nimbo or nimbus are related to precipitation. So for example, if we had a cumulus type cloud that had precipitation coming out of it, we call it a Cumulonimbus cloud. If it's a stratus cloud, we give it the name Nimbostratus. So that's where those words come from. Just briefly, I want to talk a little bit about how clouds form. For clouds to form, typically what we have to have is air that is rising up. And today is a really good example of this. And I'm going to show some pictures that I took just this morning, kind of showing what's happening. But as the sun hits the ground, it heats up that ground, and then it heats up the air right above it. And then just like a hot air balloon, you have these bubbles of air that are warmer than the air around them, and they'll start to rise up. So you've got all these invisible bubbles of air that are slowly rising up. As they rise up, those bubbles of air expand. And as they expand, they start to cool off. And typically, they're cooling off about 5.5 degrees Fahrenheit for every 1,000 feet they go up. Well, as they continue to cool, their ability to hold water vapor decreases. Finally, they get to the point where they can't hold that water vapor, or all of it, and so that water vapor has to condense to liquid water. That's called the dew point temperature, whatever the temperature that occurs at. And so as that air rises, it cools to the dew point temperature, and then you start having some of that water vapor, the gas form of water, condense into little tiny cloud droplets. And then that's when we start seeing the clouds. Now those water droplets have to condense on something else. And so those are going to be particles like dust, smoke particles, pollen, even leaf bacteria. If we had a perfectly pristine atmosphere, if we had a perfectly clean sky, you can never have clouds form, because you've got to have some type of particulates in the air to actually have that condensation taking place. Okay, enough about that. Let's go to the pictures. So the first type of cloud I want to talk about are cumulus clouds. These are these puffy, cotton ball shaped clouds, and in some cases they may mean fair weather, in some cases they may mean stormy weather. How can you tell when one's going to be and one's not going to be? Typically it depends on how tall those cumulus clouds grow. Now in the picture I'm currently showing you, these would be considered fair weather cumulus clouds. They're forming, but they don't grow very tall. And that is an indicator that you're having fair weather. Now this is, I'm going to go through a few slides here just showing what can happen. And again, I talked about this just a little bit ago. So in the morning, and today here in central Illinois was a good example of this. We started out with nothing but blue sky. As the day progresses and the ground heats up, those bubbles of air start popping up, and you start to see these little tiny cumulus clouds form. Later on in the day, those cumulus clouds start growing, becoming more numerous. And by late afternoon, you may have a whole bunch of those cumulus clouds in the sky. Then as the sun sets, you'll notice that the sky clears up again because the ground is no longer being heated up. Those bubbles of air are no longer rising. And so you go back to a blue sky or a dark sky once the sun goes down, a clear sky, I should say. So these are a couple of pictures I just took this morning. This was at 10:20 this morning. You're starting to see a few cumulus clouds just start to form. Now, the changes that can take place with these can happen pretty rapidly. 20 minutes later, look how much these clouds are growing. Becoming more numerous, and then I just took this one at noontime. So one of the things that occurs, and these are definitely fair weather cumulus, you can see they're not getting very tall at all. So these are definitely an indicator of fair weather, and probably fair weather for at least the next 24 hours or so. The other thing I want to point out with these cumulus clouds, and these are ones that are a little bit more developed, but you notice the flat bottoms on all of them. That's showing you exactly how high those bubbles of air have to rise before the condensation starts. And that's probably maybe a couple of thousand feet off the ground, maybe a little bit more, but that's how high those bubbles of air had to rise before the air cooled off enough for condensation to start. And then you notice that these clouds get a little bit taller, but they don't get very, very high at all. These would still be considered fair weather cumulus clouds. Now, another type of cumulus cloud we can talk about is Stratocumulus. These typically are found, say, after a cold front has come through. These are an indicator of very stable air conditions, so you're not going to get precipitation out of these. And again, an indication of fairly good weather. And you'll see lots of breaks in these clouds. You may see the sun shining through some of these in breaks. And a lot of times they don't cover the entire sky. Again, you'll see these typically associated with a cold front, cold air that's come through, and they don't last all that long. They may be around for a few hours, and then they may dissipate and get pushed off with the prevailing winds. This is another type of stratocumulus. This one is a little bit thicker. Now, this one's kind of getting in a fine line between stratus and stratocumulus, but you can still see kind of that puffy appearance to them. So I'm still calling it a stratocumulus cloud. Again, an indicator of stable air, so you're not going to get precipitation out of these types of clouds. A cumulus type cloud that's going to be higher up in the atmosphere, maybe at about 6,000 to maybe 15,000 feet up, are called altocumulus clouds. So you can see these have the puffy appearance to them, but they're up at a much higher elevation. When you see these, and we usually see these here in Illinois and in the Midwest in the summertime, these are an indicator that you will have a weather change probably within the next 24 hours, because these may be preceding a warm front or maybe in some cases a cold front, but it is an indicator that there is going to be a change in weather that's likely to be coming in within the next 24 hours or so. Sometimes those cumulus clouds don't stay very small. They start growing and growing and growing. And sometimes the tops of these cumulus clouds can reach up 20, 30, 40, 50, and in extreme cases, 60,000 feet above the Earth. The taller they grow, that's an indicator that the air is more unstable, which is also an indicator that you're probably going to get some type of storm being created from this. And these types of clouds, when they do have precipitation coming out of them, we call them Cumulonimbus clouds. This particular picture I took probably about a month ago. It was right as a squall line or a line of thunderstorms were getting ready to come through the area. And so this was probably about, I'd say maybe about 20 miles away from my location when this was being taken. Now these clouds are not going to continue to grow forever. They're not going to grow and grow out into space. Eventually they get to the point where their temperature inside that cloud is the same temperature as the air surrounding it. So it stops going up, it stops ascending. Once it does that, and if it is up at 30, 40,000 feet above the Earth, you have very strong winds up there. And so what happens then is the top of that cloud starts getting pushed off to one side because of those strong prevailing winds. And we call that an anvil. And the reason we call it an anvil is because it's like this little contraption that's used to forge different types of iron into different shapes. That's called an anvil, and so that's where that name anvil comes from, because the cloud top looks a lot like that anvil. In some cases, as that air is rising, even though it gets to the point where it should stop, it's got so much momentum, it continues to rise just because it can't stop itself essentially. And when you see that, you'll see that puffy top even above where that anvil is at. That's called an overshooting top. When you see that on a thunderstorm, you know that thunderstorm is a nasty thunderstorm, because if the air is so unstable that it rose up higher than it really should, that means that that's probably a pretty bad thunderstorm that you have in place there. So when you're watching thunderstorms, if you see that overshooting top, you know that that's not a good thunderstorm to be around. If you want to see a top-down view, this is a picture of actually two different thunderstorm cells, each of them with an overshooting top. Now you can see that flat anvil that's getting pushed off from left to right. So the prevailing winds are pushing that cloud top from left to right on the screen. But you've got those two overshooting tops there. So those two thunderstorms are probably carrying a pretty good punch with them. Sometimes those thunderstorms will actually start rotating. The whole thunderstorm will start rotating. And if you see this, and we do get these sometimes here in central Illinois, they're more prevalent out in the Great Plains, like in northern Texas, Oklahoma, Kansas, Nebraska, and those areas. But when you have the entire thunderstorm rotating, you can kind of see that spin to the cloud. And this is associated with a thunderstorm called a supercell. Again, you would probably see that overshooting top with it. And these are also very dangerous thunderstorms to be around. Some other types of clouds that we can look at. Now, these are more in, again, the stratus or stratiform type of clouds. We've got two different cloud forms here. Those really thin, feathery white ones that you see kind of at the top of the slide are cirrostratus clouds. Very high up, typically about 3.5 miles up or higher, and made up entirely of ice crystals, because up at that elevation it's very cold. And they're typically very thin though, so they do allow quite a bit of sunlight to come through them. Those ones down at lower levels that are more grayish, they're down, you can tell, at a lower elevation, but they're still fairly high in the atmosphere. They're in that 6,000 to 18,000 foot range. And so these are our Altostratus clouds. When you see these, especially if you see them in the west, it could be an indicator that, again, there's going to be a change in weather taking place. These clouds themselves are typically in fairly stable air, but if you do have a lot of these, and especially if they're becoming more prevalent, and it's causing a thickening of cloud cover, it is a pretty good indicator that you will have some type of weather change. And then just straight stratus clouds, very low level clouds, typically maybe only a few hundred feet, maybe up to a few thousand feet above ground. You really can't see a whole lot of form to them. It's just this gray sheet of clouds. Typically brings a very dreary day. A lot of times you'll have these when you have quite a bit of cold air in for your particular area. And you'll see this a lot of times here in the Midwest during our winter, late fall, winter, and early spring. At most, if you get anything out of them, you may get a little bit of drizzle, but again, typically it's just going to be one of those gray, dreary type of situations that you have with cold air. Here's just another picture of stratus, so you can see very well-defined layer at that. I took this one evening several years ago and thought it was just a very dramatic picture. But you can see how low that is. And sometimes it's hard to get perspective with these things. Again, the base of that stratus layer is probably, at least 1,500 feet or more off of the ground. And then you can see with these are even lower level clouds, stratus clouds, but you do have some precipitation coming out of this. These have the Nimbo name attached to the front of it. So this is Nimbostratus. You can see the rainfall coming out there around where the buildings and trees are at. These are typically not heavy rain producers, but you may just get a steady light rain associated with it. Oops. Okay, here we go. There we go. Now this is one I actually took probably about 6 weeks ago. And I just wanted to show this one. Again, the trees are not that far away. In this one, there is a pretty good amount of precipitation coming out of it. But it still wouldn't be like you would if you had a very strong cumulonimbus cloud where you could just get deluged with it. Probably a lot of you have flown in commercial jets, and you've noticed that once you get above the cloud layer, you have this beautiful picturesque view of the cloud tops. And these are just pictures of from the ground, which would appear dark gray, probably because there'd be very little sunlight coming through there, maybe a few breaks. So these are stratus and cumulus clouds, just showing it from above. Cirrus clouds. Cirrus clouds, again, are these thin, feathery clouds made up of ice crystals. If they're not thickening, if they're not covering a large portion of the sky, this would also be an indicator of fair weather. A lot of times you'll see these in the Midwest in the United States, more so in fall, winter, and springtime. If they are thickening, if they are covering a large portion of the sky, then that is an indicator of weather change. And I think I've got a few other slides that'll show that here in a second. Here's actually an indicator after a cold front has come through. Sometimes you will have a layer of cirrostratus, and this layer, you can see that very well-defined edge between the cirrostratus and blue sky. This was moving along very quickly as the cold front has already passed through, and the remnants of that is following along. That moved out of the area probably within a half an hour after I took that picture. Cirrocumulus, very rarely seen here in the Midwest. You can see how high they are. They still got that fluffy appearance to it, but they're up really high. And so we give it that Cirrocumulus name to it. These are an indicator of weather change as well, because if you've got that type of moisture up at that elevation with that type of cloud form, that's usually an indicator that you've got the beginnings of some instability. And so with that, you may be having a weather change again in the near future. You really can't be well defined in terms of number of hours or even days when that weather change will take place. These are just very general statements that I'm giving you. Here's a combination. Here we've got, if you look in some areas, you can kind of see a milky appearance to the sky. Those are those cirrostratus clouds. Again, very thin, covering a large portion of the sky. We've got the cumulus closer to the ground. When you do see that cirrostratus and you got that milky appearance to the sky, a lot of times you'll see that right before a strong winter weather storm will come in. So you've got to kind of watch that in the wintertime. When you see that coming through within about 24 to 36 hours, you could have a very strong winter storm getting ready to take place. And then, of course, we've got a cloud at ground level. We see this, a lot of times we call this fog. And that reason the fog forms at ground level is because the air right above the ground has cooled down to that dew point temperature for maybe dozens or hundreds of feet above the ground. And so that water vapor has condensed and created water droplets. And so that's why we get fog. A lot of times that happens at nighttime as that air cools. It cools down to the dew point temperature, especially when you have very calm winds and clear skies. And if that fog is thin enough, you may actually get a rainbow associated with it, and that's called a fogbow. All right, now I want to show a few other clouds. Some of these you may have seen in certain cases. Several of these, I know the majority of you will have seen these. Some others may be fairly unique. Probably a lot of folks have seen this one. This is a very ominous looking cloud. It's called a shelf cloud. You can see that rain in the bottom of the slide. So this is ahead of a squall line, a line of thunderstorms. And what's happening, you can see the base of that cloud is very close to the ground. You've got very warm, moist air out ahead of this thunderstorm that's being brought into that thunderstorm. And that air does not have to rise very far off the ground to have condensation start. So as that air is being brought into that cloud, it condenses and creates that shelf cloud. Now, along with that, as that shelf cloud moves over, you may get a whoosh of wind that comes along with it. That's actually called a gust front, and that's actually from part of the thunderstorm where you've got a downdraft. Once that downdraft hits the ground, some of it spreads out to the back, some of it spreads out to the front, and that gust front kind of follows along, right along about where that shelf cloud is at. So as the shelf cloud comes over, you get that gust front, and then immediately after that is typically when the precipitation starts. As those cumulus clouds start to get taller and taller, right at the very top, once they get up to a higher enough elevation, some of that water starts changing, those water droplets start changing into ice particles. And so you get this very smooth little top to that before it's gotten to the point where an anvil has occurred or has formed. But this is the very beginning stage of that. You're starting to get these little ice crystals form. It kind of forms a cap on the top of that growing cumulus cloud. We call this a pileus, which means skull cap. Now this one is really cool. And it's kind of hard to get a good perspective with this, but we have these altocumulus clouds, and then you've got this nice circle in there, and then it looks like what you have are cirrus clouds in there. And this is called a hole punch cloud. So what's actually happening here is the altocumulus is down actually below those cirrus clouds. The cirrus clouds have some ice crystals that are falling through that altocumulus layer. What ice crystals do is they will actually rob that cloud of its water droplets. And so that goes into those ice crystals. And so as it removes those water droplets, you have that hole punch that's created there. So that's created by ice crystals falling through a lower cloud level, robbing the water droplets out of it. Probably a lot of folks have seen these clouds. These are kind of pretty clouds too. The scientific name for it is Altocumulus undulatus. But what is causing these clouds is up at that elevation, try to picture the wind acting kind of like a roller coaster where it's going up and down. Where the air rises, it cools, condenses, forms a layer of clouds. Where it sinks, it warms up. No clouds. Where it rises again, another layer of clouds. Air is very turbulent and can cause a lot of different things going on. It's not just air moving all in one direction, rising, sinking. You have lots of turbulence in the atmosphere. And I'm not sure where those marks come from. I apologize for that. If anybody put those on there, I hope you can erase them. Now with these, probably a lot of people have seen these. It looks like precipitation is coming out of these clouds, and actually it is. But the air below it is so dry, it's evaporating before it hits the ground. So these are called virga. Now, if you were right underneath one of these, you may get a few singular drops, but essentially that air is so dry, it's not hitting the ground. One of the things that happens, thank you for getting those removed. One of the things that will happen is if you have a lot of these continuing throughout the day, it will moisten up the air below it. And eventually that air may be moistened enough that more of that precipitation will eventually hit the ground. But at this point, very little of it or none of it is hitting the ground in this case. Now, this is one that you really have to watch for in terms of tornadoes. if you see kind of in the mid portion, right where that cloud is flat, but then you've got this low hanging cloud right in the middle of the picture. That's called a wall cloud. And actually, if you could see that in real life, you might actually see a little bit of rotation occurring with it. A lot of times these types of clouds are associated with supercells. And so it's kind of a rotation within a rotation. This is an area that has a really good chance of a funnel cloud forming at it going on down to the ground. So these particular types of clouds you really have to keep an eye on, because these are ones where tornadoes can form out of them. This one is a really cool cloud too. I've only seen these once or twice, but they are really neat to see. These are roll clouds. Now they look kind of ominous, but it's not something that tornadoes are going to form out of. This is typically following a thunderstorm, or it maybe actually moves out ahead of a thunderstorm or a cold front. And what is happening, again, it's a relatively low cloud, just maybe 1,000 or 2,000 feet up, if that. But if you could see, that entire cloud would be rolling along. And so what you've got are two different types of air masses, and you've got enough turbulence there that it's actually causing that rolling of the air, which is also making the cloud itself roll. As that cloud will move over your location, you may get a little gust of wind associated with that change in air mass. But again, it's not something that is going to typically be a really high wind speed associated with it. You're not going to get tornadoes out of it, but they are really, really cool to see. This is also one that scares a lot of people. This is something associated with a thunderstorm. These are called Mammatus clouds. They look very dramatic. They look very scary. You got these low, droopy pouches of cloud associated with that cumulonimbus cloud. Typically, when we see these, and especially when they look so dramatic, it's after the thunderstorm has already passed us. Most of the time here in the Midwest, when we get thunderstorms, they're typically coming out of the west, moving towards the east. Once those thunderstorms have passed over, and if the sun is back out, the sun will be shining on those thunderstorms and on those Mammatus clouds, and they look very ominous. But that is not where the tornadoes form out of. Again, they look very dramatic, and here's one where you don't have the sunlight on them. Again, very, very neat looking otherwise, but this is not there. It is showing a lot of turbulence within that thunderstorm, but this is not where you'll have funnels forming out of. And a lot of times, by the time you see these, the thunderstorm has already passed by. One that has just gotten a relatively new name associated with it are clouds when you've got a lot of turbulence in the air, maybe associated with a front that's getting ready to pass through, or a storm front getting, squall line getting ready to pass through. And you see all of that turbulence in the clouds. And these are called Asperatus clouds. It just means basically agitated waves of clouds. These clouds are not ones that you're going to find here in Pancake, Flatville, Midwestern part of the United States. You will see them out over mountain ranges. And if you notice, you've got the one line of clouds kind of at the top of the slide, and then one in the middle, and then another one kind of associated with the mountaintops. These are called lenticular clouds. They kind of have a lens shape to them. And what's happening there is air is being forced up the mountains. As it's forced up, the air cools, condenses. You have a layer of clouds that forms kind of along the tops of the mountains. But once it's risen up like that and it continues on, it starts doing that roller coaster thing where the air rises, sinks, rises, and sinks. And so what you get is a series of these types of clouds. So where you see the blue sky, that's where the air is sinking, so you don't have clouds. Where the air rises, you have these clouds. The other thing that can be happening is several thousand feet higher, that roller coaster thing is happening in the air above it. So you may have a same type of lenticular cloud happening higher up in the sky, kind of mimicking what's happening below. This one is a very neat one too. If you can see kind of in the lower left-hand side of the slide, there's an island sitting out in the ocean that has a pretty tall mountain associated with it. And the wind, in this case, is moving from the lower left-hand side of the slide to the upper right-hand side. So as the air moves around that mountain, it makes the air kind of move apart, which in turn makes the clouds move apart. And then you get the swirling motion associated with it. These are called Karmen vortices. Here's a satellite view of the same thing. Again, the air would be moving from the bottom of the slide up towards the top. And so you can see how much turbulence air just moving around a mountain like that will cause. So there's so many different ways that air can move around in different ways. And that's one of the reasons why it's so hard in some cases to do long-term predictions, because you've got so many of these different little small scale things that are taking place that can affect things over the long run. Even temperature differences can make a difference in the way the cloud looks. So this is a satellite view of some cloud tops over the Aleutian Islands. Really no difference in these clouds other than their temperatures. Now this isn't a enhanced color image, computer enhanced image. This is what the clouds actually look like, but it's simply because of differences in temperature. If you're around a mountainous area, what's happening in this case is air is moving up off of the water. As it moves up, it cools, condenses, and you have clouds form at the top of that mountain. The air continues to go on past the mountaintop and will sink back down. So the air continues to move, but the cloud doesn't. This is called an orographic cloud. So as long as that air continues to move up and over the mountain, that cloud will continue to be there. This cloud, the Horseshoe Vortex, I have never seen myself. These are very rare types of clouds because they only last in some cases maybe 5 minutes. Again, it's kind of hard to get perspective with this, but in a lot of cases, this cloud actually starts out more in a horizontal fashion. But what happens is the air below is rising up and it will actually bend this cloud. It's kind of a higher level type of roll cloud, so it's actually spinning. But what will happen is air from down at lower levels will rise up and kind of bend that cloud into a U shape. And so if you could actually see it, it's actually spinning. Again, it doesn't last very long, maybe 5, 10, 15 minutes, and then it dissipates. This type of cloud, probably a lot of people have seen it. And it looks like you've got waves up at the top of the cloud. What's happening there is you've got a difference in the direction that the winds are going. And so what it actually does is it shears off the top of that cloud and makes that wave appearance. These are called Kelvin-Helmholtz Clouds. These may be also an indicator of weather changes that can be taking place or may get ready to take place. Here's just another picture of them. Very neat to see. Yeah, I know, I got to get a life. Now, these clouds are not normal type of clouds that you and I would see around here, or really in almost all of the world. The only place you're really going to see these are over the poles. These are called Nacreous Clouds or polar stratospheric clouds. These are clouds that are going to be up 50 or probably 60, 70,000 feet up. They're not in the troposphere, that layer closest to the Earth. They're in the next layer of the atmosphere that we call the stratosphere. Very colorful, But these clouds are different in two ways. For one, they're at a much higher elevation than what our normal clouds would be. And they contain something besides what our normal clouds do. Most of our clouds in the troposphere are made up of liquid water or frozen water. These clouds do contain frozen water, but they also contain frozen nitric acid. And because they're up at such a high elevation and they're at the poles, again, these would be forming above the North or South Pole, typically during their winter time. In that area, probably a lot of folks have heard of the polar vortex. These things usually form during the winter time for each respective pole, but these clouds will form within that polar vortex. And then as the sun starts coming back and hitting the top layer of the atmosphere, which it will do first before it hits the ground, as that sun slowly returns, have these very colorful, very pretty clouds associated with it. Now, for anyone that is interested in the ozone hole that forms especially over the South Pole, those types of clouds do play a part in that ozone hole, because with that nitric acid in them, they have the ability to split apart the chlorofluorocarbons that may be present, which separates the chlorine out, which then can destroy ozone. And again, too much chemistry to even talk about that today. So just mention that in passing. Now, what are these? We got these long, straight clouds associated with this area. This is a satellite view. And no, if you're up in a space station, you would not see the individual lines of the states. But these are all formed from jet engine emissions. These are contrails. Back in the 1970s, 1980s, there was a lot of concern about these, and you can see how much they're covering the southeastern part of the United States in this slide. There was concern that there would be so much of this in so many cases that it would actually cut down on the amount of sunlight in particular areas. Don't really hear as much about that now because jet engines have become a lot more efficient in terms of their emissions. You don't see these contrails forming these big wide areas of essentially stratus layer types of formations. So it's not quite as much of a concern as it was back 20, 30, 40 years ago. This one I just put in there, I thought it was really cool. So it's again a picture from space, but it's showing a rocket shooting through a stratus layer going up into space. And then you saw this on the very first slide. This is again a picture of a cumulonimbus cloud with the big anvil associated with it, a little bit of an overshooting top there where you see the clouds bubbling up through that anvil. And then this one, I just put in there because it's a picture very close to where I grew up. And I just thought it was a very cool picture, very pleasing to the eye. So I just included that one in there. It's got some Stratocumulus and some other cumulus that are growing up a little bit in the background. A couple of things I wanted to finish up with. A lot of times you'll hear the weathercasters talking about a day being partly sunny, partly cloudy, fair, all of those things. And sometimes it can sound kind of confusing, but there's actually some reasoning behind these clouds. According to the National Weather Service, the term partly sunny is supposed to be used just during the day, and you're supposed to use the term partly cloudy at night. And when it's between 3/8 and 5/8 of the sky is covered by clouds, that's when you use the term partly cloudy during the day, partly cloudy at nighttime, partly sunny during the day. Mostly cloudy means there's more clouds than sun, or more clouds than stars at night. According to the National Weather Service, the sky is classified as mostly cloudy when you've got 3/4 to 7/8 of the sky that's covered by clouds. When you hear the term mostly sunny, that's when 1/8 to 1/4 of the sky is covered by clouds. Or if it's at nighttime, it would be mostly clear. And then if it's just sunny or clear, that means there's no clouds in the sky. And probably one of the terms that's not used very well at all is the term fair. National Weather Service will use that at nighttime when there's less than 3/8 cloud cover. And when you don't have any precipitation, when you don't have any hazy sky, or any other extremes taking place. Generally means just nice, pleasant weather. And no, there will not be a quiz on that. So like I said, we're going to be finishing up. This is the last of our weekly webinar series. We're going to take a little bit of a break for the next few weeks and through July. We're going to be coming back in August and doing this on a monthly basis. And really hope that you enjoy these types of webinars. We will be continuing them on a multitude of different types of environmental subjects. If there are particular things that you would like to see, again, on the survey, that will have a QR code showing up here in just a second. But our monthly webinars are going to be held on the second Thursday of the month, starting at 1 p.m. So again, be watching for that. So with that, we've got some time for questions. And so Aaron, if there are questions, if you want to give them to me, I'll see if I can answer them.
All right, thank you, Duane. One just technical issue right now is the survey doesn't look like it was published because it's asking for a login. So after today, if you would like to check on that, and I know we typically have follow-up emails, we can send that
sorry
link
about
again.
that.
That's okay.
Yeah, we will resend the link out, and then you can do that at your leisure.
Perfect. And we did also have a couple requests for you to share the PowerPoint. I don't know if you were planning to do that or not, but just want to let you know those did come in, so you can decide on that.
Okay.
And then for questions, we had one that was if you could describe the difference between wall clouds and shelf clouds.
Okay, good question. A shelf cloud is typically at the front of a thunderstorm that's coming in. It's air that's being brought in kind of if the thunderstorm is moving towards you, for example, that shelf cloud is going to be right ahead of the thunderstorm itself. A wall cloud is typically going to be associated with a rotating supercell. It's not going to be right at the beginning of that thunderstorm as it's approaching you. It's going to be more towards the rear end of that thunderstorm, if that's making sense. So, if you have a supercell that's approaching you, you're not going to see that wall cloud as it's approaching you. It's typically, again, going to be more in the back quadrant of that supercell. And where a shelf cloud is more of an elongated type of cloud, the wall cloud itself is just kind of one small area of low-hanging cloud. And it may actually be rotating, and that's another big difference. The shelf cloud, you don't have rotation associated with that. With a wall cloud, you may actually see rotation within the wall cloud itself. So again, you've got rotation within the wall cloud because the air is rising up very rapidly, and as it does, it starts rotating. If that rotation becomes strong enough, you'll have a funnel that will go ahead and come down to the ground. Good question.
Okay, thank you. Another question is, with the dust cloud blowing to the U.S. from the Sahara, should we be expecting cloudy weather as dust particles would allow moisture to accumulate around them?
Very good question, and I kind of anticipated someone asking that. Well, if you do notice, for the Midwest, we do have about a 50-50 chance of precipitation over the weekend, and that dust plume over the middle part of the United States, I think, is supposed to reach its height around Saturday. Yes, the more particulates you have in the air, the more potential you have for precipitation. Now, the thing that has to be in place is the moisture aspect of it. And if you have enough unstable air, you can have that dust in the air, but you won't necessarily have precipitation with it just because those particulates are there. You know, a prime example is where that dust plume started. It started in the Sahara Desert. You don't have precipitation there because you have very strong high pressure capping that off, stopping that air from rising up very high. So if you have that, probably more what we can expect is maybe some really spectacular looking sunrises and sunsets. And we may have very hazy looking skies during the day. But yes, you can have precipitation associated with particulates. Another prime example of that is when you have a volcanic eruption and you get all that volcanic ash into the air, that can lead to very heavy precipitation events from those particulates being present. Another really good question.
Okay, our next question is if you know if there's any training to be a storm spotter.
Those are usually done seasonally. They're done by the National Weather Service. Typically, they do that in late February, early March. So if you go to the National Weather Service website for your local area, for Illinois or other areas, they typically will show when the next storm spotter training is going to take place. Typically not a very long training event, about 90 minutes, but it'll give you the basics of what you need to look for in clouds and storms in general to be able to describe different potential severe weather events that may be approaching.
Great, thank you.
Mm-hmm.
Someone was asking if you have a suggestion of a good reference, and I assume that's for cloud identification.
In terms of books, I don't, but if you really want to get into clouds and their scientific names and just looking at many different types of clouds, and it will also then relate to, you can get to different places where you can get a little bit more scientific definitions and those types of things. And if you don't want to do that, if you just like looking at clouds, one thing that's really, one site that's really interesting is something called the Cloud Appreciation Society. It's actually a British society, but it's got a multitude, just thousands of different types of cloud photos. And they have a cloud of the month. They send out a newsletter and everything. You know, it's not a professional endorsement, but it's really a good source for looking at just many different types of cloud forms out there.
Great, I'm gonna have to check that out. That sounds really interesting. Okay, next question is there any scientific basis to seeding clouds for rain?
Oh, yes, absolutely. And actually in California, they have proven over the years, because that's an area where they do cloud seeding pretty regularly, it will raise the amount of normal precipitation, normal annual precipitation, somewhere around 10%. Now, cloud seeding, what it does is it tries to mimic some of those particulates that are in the air. You can't go out, say here in central Illinois on a day like today, and cloud seed and expect to get a thunderstorm to build up. You've got to have the right conditions. You've got to have the moisture. You've got to have enough instability for those clouds to continue to build and form precipitation. So it's not something that you can do everywhere. And again, you're not going to get huge amounts of precipitation out of this, but in some places under the right conditions, it has been shown that it will increase the overall amount of precipitation slightly. So they have used this out in Northern California for years and years. And what it uses is something called silver iodide. It's something that has a lot of the very same qualities as some of those other particulates that are in the air, like the pollen, the leaf bacteria, and those kind of things.
Very interesting. The next question, I believe, refers to one of the later pictures that you showed. And they were asking if you know what the temperatures or relative temperature differences are between the clouds of the 3 different colors.
Oh, that's a really good question. And unfortunately, I don't. I saw that picture one time and just thought it was really neat. And it basically was just talking about cloud temperatures, and it didn't relate to what the temperatures were. Probably if you could go back and find the infrared satellite viewing of it, you could get that information. But I don't know. I've had that picture for years and years, and unfortunately, there wasn't a, from what I could tell, a satellite infrared image to go along with it. So I apologize. I don't have that information.
All right, and I think our last question, at least for right now, is are hurricane clouds a special cloud formation?
Well, they're going to be the cumulonimbus clouds, especially in the eye wall and in the spiral bands. You're going to have cirrus clouds up at the top. So it's a lot of the very same clouds that we talked about. And hurricanes, again, the whole storm system is slowly spinning. But one of the big things with hurricanes, and I didn't mention this with clouds, but when clouds start to form, when that water vapor condenses into liquid droplets, it actually releases a little bit of heat into the surrounding air. It's called latent heat that's released. Hurricanes are one way that it moves a lot of heat from those warm tropical waters into the middle latitudes, because you have huge amounts of condensation taking place while that hurricane is moving. And typically those hurricanes are moving out of tropical or subtropical areas, away from those closer, more towards the north or south, depending on which hemisphere they're in. So they're one big way that they actually help move some of that surplus heat from the tropics away from the tropics into the middle latitudes. Kind of off topic, but.
Very cool. And one question just came in during that explanation that asked, are those what is sometimes called thunderheads?
Well, thunderheads are, associated with those cumulonimbus clouds. So as that cumulus cloud rises up, that's when you start getting those thunderheads. Yep, exactly.
Perfect. Okay, that is all the questions that have come in as of right now, and we're perfect timing. We did get some feedback that the QR code does work, so it must be something with the link, but I was trying to get a login from Qualtrics, so I don't know what's going on with that, but we'll get it sorted out.
Okay, very good. Thank you, everyone.
Thank you, Duane.